2024 was a great year for AI agents. If that's any indication, it means 2025 is going to be an even greater year. In today's video, we'll look into the landscape and the use cases and some of the agentic patterns, as well as how to get started for building agents in 2025. A couple of weeks ago, Anthropic released this paper named Building Effective Agents. We're going to take a look at some of Anthropic's recommendations as well as patterns from this paper, along with some of our own experiences from building AI agents for the last couple of years. Now, let's first define what an agent means, because different frameworks define it differently. For the most general cases, an agent is simply an LLM with a system prompt, tools, and memory. So that's the simplest definition for an agent. Of course, different frameworks and different LLMs support varying capabilities when it comes to agentic flows. OpenAI may support different capabilities from Anthropic, from the open source Ollama models, but at its core, at the minimum set of features, an agent is something you can call an LLM with a system prompt, tools, as well as in a memory, either in-store memory or persistent memory. This is the general industry definition. Let's take a look at Anthropic's definition in the paper. So in the paper, Anthropic makes a distinction between agents as well as workflows. So for them, LLMs and tools are orchestrated through predefined code paths. So that's a workflow. Agents, on the other hand, are more autonomous and they can dynamically connect to LLMs and make certain decisions. So that's a small differentiation that Anthropic puts together, but for the majority of the industry, agents are systems that can be orchestrated, can be put together, can be specialized to accomplishing certain tasks. When it comes to when to use agents, Anthropic also makes some recommendations. And at the core of the paper is simple is better. If the use case is not super complicated and it doesn't require agentic flows, then the simpler the better. That's mainly the message from the paper. When more complexity is required, then workflows perhaps offer more predictability. And then lastly, agents perhaps are the more capable, but also kind of sometimes less deterministic. So next, Anthropic makes a list of frameworks that are available in this space. And they list LangGraph, Amazon's own Bedrock, of course. Since Anthropic is an Amazon-backed company, it makes sense for Bedrock to be in the list. And then Rivet and Vellum are two other examples. But as we'll see later, there is a number of frameworks available. LangGraph and LangChain are some of the more established frameworks, but there are newcomers into the space that offer similar functionality, perhaps even simpler interfaces, more Pythonic implementations. It's a good thing for Anthropic to put a list of frameworks that are available. At least someone can take a look before they start building their agentic flows. However, as mentioned, LangGraph is one of the more established frameworks. We've done a few videos. We have a slide on LangGraph Tutorials. In the space of LangGraph, they offer different architectures. One of the architectures that LangGraph does well is the router architecture, where you have multiple agents connecting through memory, as well as you have conditional edges, you have edges among agents, and you can deterministically route the logic flow inside the LangGraph agent network. By the same token, LangGraph supports React, which is reasoning and action together. And in the React framework, there's a supervisor agent and there are worker agents where tasks are distributed among them. A different architecture, but still supported by LangGraph. So it's a very well established and very well used. It has a large user base. It's an open source framework, has a large support for tools and models, and it has a great user base and GitHub community. The other framework, although not listed, but equally well established and has a large user base, especially in Europe, is Microsoft Autogen. And Microsoft Autogen was one of the earlier agentic frameworks supporting, again, React style supervisor agents as well as router agents. It supports memory and tools and has a large user base, has support for Python as well as JavaScript and other languages. It's a great framework to get started with if the enterprise integration architecture is already on Azure Stack or uses Microsoft tools. Autogen is definitely an agentic framework worth taking a look at. Now, the next one will be the Amazon Bedrock. And Amazon Bedrock is similar to Autogen in the sense that if The company is already invested in AWS, and it has a large set of web services that are running on AWS infrastructure. It makes sense to use Bedrock services for LLMs for different models. They have support for all Anthropic as well as other models, both open source and commercial models. So Bedrock is a great LLM agentic framework base if the company is already integrated well within the AWS ecosystem. AWS is traditionally very well documented as well as supported, and it's very easy to get started with free credits, especially with some of the Bedrock open source models. Next up is the Rivet. In Rivet and Vellum, the next one are UI-based agentic frameworks where you can use what you see is what you get editors to basically drag and drop agents. If you've used any of the open source alternatives such as Flowise, you will be familiar with this, and they provide a viable alternative to the code-based agentic systems. We'll talk about the differences later. For now, we'll just cover these couple of frameworks that are a good starting point. This is open source, by the way. They also have an enterprise plan, but you can start free basically with Rivet. The next one is Vellum. Vellum is not open source, it's a commercial product. Vellum offers a similar user experience. It is beginner friendly, the UI is intuitive, and you can create capable agentic flows through the UI. But the space is really large. These couple of frameworks are listed in Anthropic's paper, but just so you have a sense, the number of frameworks and tools is growing by the day. There's a large percent of new companies coming up almost on a daily basis, and it's sometimes hard to keep up with that. So just to have a sense of some of the tools available on the marketplace, I put together this slide as of September 2024, which is 4 months old already. There are a couple of hundred vendors or frameworks available in this list. As you can see, some of the tools you may be familiar with. Flowise is their CrewAI is one of the also very capable agentic frameworks. We see Autogen, MemGPT, Octoverse, AgentOps is there, as well as Vertex AI, which is a Google company. And as you can see on the left side, you have the agent builder frameworks, and on the right hand side, you have the coding agents that, for example, Cursor is a great platform for code generation. You have Codium, of course, Microsoft partnering with GitHub Copilot is there. And so there's a lot of agents that are producing viable code that, if not production ready, at least it's 60, 70, 80% production ready. And with some modifications, it can be put into production. So we see other categories: productivity, customer service, data analysis, personal assistance, workflows, research. The landscape is large. So at some point, it really becomes confusing how to get started. And one of the easiest ways to think about agentic frameworks in 2025 is to categorize them according to capabilities and training requirements. So one of the ways you can categorize them is based on the skill sets on your team, as we'll see later. And so would you have more people that are coders and developers, or do you have people that are more visual designers? So with that in mind, there are basically two categories of agentic frameworks: visual frameworks and coding frameworks. In the visual space, some of the alternatives here are FlowiseAI, Rivet, LangFlow, chat-based semantic kernel from Microsoft. In the coding space, we have LangChain, LangGraph, Autogen from Microsoft. Llama Index is another very capable framework, and a newcomer to the space is PydanticAI, which offers one of the easiest ways to get onboarded into a Python-based agentic flow with some minimal coding. They use idiomatic Python, which is very easy to get started, and creating an agent is as simple as 5 lines of code. For LangChain and LangGraph, we have tutorials on this channel, so I would highly recommend to check out the LangGraph Tutorials. In these tutorials, we talk about how to construct an agent framework, how to use constructs such as memory, conditional flows, as well as how to persist memory. We have 2 full examples of multi-agent frameworks. In one case, 7 agents writing software code. In the other case, we have 6 agents doing financial research. So quite a bit of examples on the LangChain, LangGraph ecosystem. And if you'd like to get started with building agents, PydanticAI is an amazing choice because it's simpler than LangGraph. It's easier to get started, and we have great tutorials in the masterclass on PydanticAI, starting from AI agents, simple agents, then to using Logfire, getting structured outputs from the LLM codes, and finally system prompts that make a true difference in the performance of our agents. Okay, that's really great. We have frameworks, we have a landscape of both commercial and open source tools. We have some ways to get started, but what are some of the use cases that agents will be used in 2025? Well, if we take a look at the use cases, we see immediately that customer support or customer agents is one of the first use cases that AI and chatbots have been traditionally deployed for the last 2-3 years. And we'll see that in 2025 that will continue to expand and agents will become even more important in customer support tasks. So think about banking, think about insurance, think about healthcare, think about financial services, anything where a customer is interacting with a company or a product. An agent-based AI system can make a true difference, especially when enriched with these tools and contexts that we mentioned before, where the agent will get the customer data beforehand, and then based on the contextual customer data can answer questions in a meaningful way. That will make a great difference in the overall user experience. Next, we have employee agents. These are agents that will perform tasks at the workplace. So you will start seeing coder agents. You will start seeing system analysts. You will start seeing tester agents. You will start, specifically speaking here in software teams, but in HR, you'll see more and more screening agents for candidates. In medical settings, you'll see agents helping medical doctors with all sorts of data analysis, imagery analysis, telemetry, and all sorts of other things. In chemical industries, in nanotechnology, in clean tech, in clean energy, you will see these employee agents pop up and start taking more and more share of the workforce, really helping augmenting the workforce with meaningful outputs. Next, we talked about coding agents a little bit, but we'll see a lot more both from coding assistant, copilots in tools such as GitHub Copilot in Visual Studio, but we'll see them popping everywhere. So all SaaS platforms, Microsoft, Salesforce, some of the Apple enterprise products, they will have coding assistants embedded in these products. Then we're going to have data agents that will combine capabilities of data gathering, cleansing the data, and compiling as well as classifying the data. Cybersecurity agents will have different tasks in guarding data and protecting websites and sensitive data. And finally, creative agents is another field where already we're seeing a lot of developments in the space of video creation, image creation. AI agents have made a big difference in the creative space, so that will just continue to grow. Okay, what are some of the other use cases? Briefly, this is a list of other possibilities where agents will be involved. I'm not going to go over the entire list, but just a couple examples that in education, for example, enhanced learning outcomes can be achieved through agents, fraud detection, IT automation, improved system reliability, research and development. All of these fields will see their fair share of agent infusion in 2025. All right. So these are some of the use cases. I hope that you will find parallels between your work and some of the use cases. And if your industry or your field of work is not listed, perhaps you can chime in the comments and tell us, maybe share with the community how agents in 2025 will impact your line of work. Are they going to be a helpful assistant? Are they going to make your job easier? Can they automate some of the mundane and repetitive tasks? How can agents improve your job in 2025? Please post a comment and share with the community. Next up, let's take a look at the agent patterns. And these are again listed by Anthropic in the paper. So let's take a look at some of the patterns and start with the augmented LLM. Anthropic lists workflows and agents as two separate concepts for them. In this realm of workflows, this is their first simplest workflow. And this is very similar to our classic agent definition, which is an LLM call which has access to tools, has its own memory, and has its own system prompt. So this workflow here is basically a classic RAG or retrieval augmented generation workflow, where the LLM gets results from a database, typically a vector database, then uses tools, potentially, optionally uses some tools, and then it can access memory to get context of previous messages and finally produces the output. So this is the simplest agent workflow pattern according to Anthropic. In the next pattern, we're going to look at prompt chaining. And prompt chaining can be very effective, especially when decomposing a task into a sequence of steps. And why is this important? Because sometimes a large task, if a large prompt or a big task is given to an LLM, the results are not as good. So for example, if I go and ask ChatGPT or an OpenAI model to build me a website for e-commerce, that's a very, very big ask. This needs to be broken down into smaller tasks. So what can potentially be broken down? For instance, build me the backend of an e-commerce website. So that's one task to be broken. In the backend, for example, build me the microservices infrastructure for an Amazon Web Services backend for an e-commerce website, which will use Salesforce, is a lot more specific. And you can get deeper and deeper into detail, but prompt chaining is a mechanism where you can break up a task to smaller chunks of prompts and then provide them as separate agentic flows to get better results. And that's one of the patterns or workflows that Anthropic has recommended as best practice in their paper. Next up is routing. And routing is also an interesting workflow pattern. And in the router case, you have the LLM router, which then determines to which LLM call to route the request. Each one of those LLM call 1, 2, and 3 are specialized in a specific task. They have their own system prompts, maybe access to specific tools, or even different LLMs. So the first LLM could use a fine-tuned LLM. Imagine a medical scenario where each LLM is specialized in different medical fields. So you could have internal medicine fine-tuned model, you could have holistic medicine, and you can have oncology or some other fields. And then the router call could direct the call based on the user's question, or if this is a customer support call or a doctor interface, maybe a reference check can direct it to the right LLM and produce a better output. This is a great pattern that Anthropic has recognized and put in the paper. Routing is one of the workflow patterns recognized as an effective way to break up larger LLM calls into smaller specialized routed calls. Next up is parallelization. And this is very similar to route, except a task is then divided into multiple chunks and is spread across multiple LLM calls. And this is usually done to improve the efficiency of a call. If something takes too long, then a smaller task get faster, and then you have an aggregator function. The utility for this is more narrow than the routing, but there are fields where massively parallel calls could improve the outcomes and could shorten the time to answer. Okay, we're continuing these patterns that Anthropic has recognized. And next up in the list is the Orchestrator-workers. Now, the Orchestrator-workers is again similar to the routing, but except now you have an orchestrator or a supervisor. This is also very similar to the React style supervisor agent network that LangGraph supports. And you have an orchestrator which then breaks down the tasks. The job of the orchestrator is to create a plan with tasks and then distribute these tasks to the different agents. As mentioned earlier in the LangGraph tutorials, we have a tutorial on financial research agents, and the financial research agents use this style of orchestration. You have a supervisor agent which then distributes the task to the appropriate agent when needed. So not all agents will be called all the time, but if there's a need for financial research, in our example, we're doing a financial research on world economics data. So if there is a need for GDP for a country or the gas prices, there are specialized agents equipped with the tools to grab these GDP and financial data. So our orchestrator or supervisor node knows how to route the calls to these agents, then put them back into the synthesizer node, and the synthesizer then combines the answer and puts the output. So this orchestrator workflow is one of the most useful workflows. It's similar to the router, but it's also slightly different. Next up is Evaluator-optimizer. And with the Evaluator-optimizer, the pattern is one LLM can generate a response while another provides evaluation and feedback inside the loop. This example we've also used in our previous examples on this channel, where we have two agents. We have a coder agent and code reviewer agent. Now the coder agent produces software code and it sends it to the reviewer. Reviewer then reviews the code and sends the code review comments along with a code quality score back to the coder agent. The coder agent then takes those comments and the quality score and improves the code according to the comments and sends it back to the evaluator or code reviewer. And this cycle can repeat several times until the code quality threshold is met or the number of iterations is complete. So this is just one example of this pattern, and it's a very useful pattern for building agentic flows. Now, next one is the autonomous agents. And in the case of autonomous agents, this is similar to the Microsoft Autogen framework. These are mostly used for open-ended problems. Here, a human makes a call to the LLM, and the LLM does an action from its environment. This could be calling a tool, this could be calling a RAG, or anything else. Then a feedback is received, and based on that feedback, that action may be repeated multiple times, but the LLM makes a decision what to do. The environment there, it could be other agents, could be other system, could be downstream system, but the LLM makes these number of calls until a condition is satisfied and an answer is able to be provided. Finally, it goes to the stop stage after a certain threshold or some certain number of times, or when the answer is obtained. So autonomous agents are also quite well used, and certain frameworks rely on this. The problem with some of the autonomous agents is the unpredictability of these loops. Sometimes this could be an issue with costs, and sometimes it could be an issue with the performance of the agentic network. So special care must be taken with autonomous agents. They're less predictable, less deterministic than some of the other workflow patterns. Let's take a look at an example of a coding agent. This is a simple sequence diagram of human interacting with a coding agent. There's a query, and the typical query is write me code for X, Y, and Z. Let's say an online banking system sign up form. And here the interface, if it's a chat interface, takes the question, passes it to the LLM along with the context. LLM then interacts with its environment. Again, the environment here could be other LLMs, could be other agents, could be RAG systems, could be the file system, could be anything else, and writes code and then writes some tests and then runs the test. We also have examples on this channel of creating Python code and executing the Python code in a REPL environment. And if the code passes, then that's okay. The agent can continue to the next step, or if the code fails, maybe there will be a loop to rewrite the agent. So it's a really, really good example of how to use a coding agent in a loop. And once it's complete, then the results are then sent to the interface and displayed back to the human. Okay, so we've seen some of the patterns of what Anthropic classifies as workflows. Now let's talk about how to choose a framework, because we have so many frameworks and so many different architectures and patterns. It's sometimes difficult to choose a framework. In this case, we're going to list 6 different ways how to choose this. In these 6 different ways how to choose the frameworks are the use case, the nature of the use case, the criticality of the project. Is this a mission critical application? Is it an enterprise application? What is at stake? Team skills. What are the skills on the team for this? This is important when choosing a visual versus coding framework. Do we have the right Python skills on the team? Do we have the right TypeScript skills on the team? Or is it a more visual team of designers? Then that could determine which framework to choose. Do we have low code, no code preferences on the team? Or do we have good coding skills and knowledge on the team, which can then enable us to choose some of the more highly customizable frameworks such as LangChain, LangGraph, or PydanticAI. Next is time and budget. What is the time frame and what is the budget for the project? Then the integration with downstream systems. This is so important. What cloud provider are we on? What systems do we have? How do we integrate with these systems? This is so important when choosing the framework. If we're on AWS, we may consider Bedrock. If we're on Azure, we may consider Azure OpenAI or some of the Microsoft Autogen frameworks. If we're on Google Cloud, we may then go and look at Vertex or other Google solutions. So that could be a key factor in determining which agentic framework to try. Along with that is also the AI ops, which includes the cost of the platform, the maintenance, security, data reliability, as well as privacy and data residency laws. So all of this goes into AI ops, and it's so important that could determine which framework to choose. Now let's take a look at the visual and the low or no code solution. One of those solutions is FlowiseAI. If you've had a chance to interact with Flowise, you'll see how easy it is to get started with Flowise. The installation is rather straightforward. It's a node-based application that installs locally. They have hosted models as well, but it's largely a drag and drop system where you can have nodes and then drag arrows from one node to the other. Underlying infrastructure for Flowise is LangChain and LangGraph. They support creation of agents as well as custom tools, a large number of LLM providers, RAG systems, as well as local document stores and vector stores. So it's a great system to take a look at if you're beginning your journey into building AI agents in 2025 and you would like a low code or a no code solution. FlowiseAI is one of the best frameworks to start with. Next up is PydanticAI for those who are coders and who would like to start with a simple framework. It's one of the newer frameworks, and we have a series on this channel on PydanticAI. It's super easy to get started. Creating agents, creating tools and system prompts, as well as memory for agents is straightforward, and it has excellent documentation and support in the open source community. So PydanticAI is one of the great choices for getting started. Now let's take a look at some of the resources available, and let's start with some of the no-code resources. We're going to have a list of slides for these, starting with the no-code or low-code solution. So LangFlow is one of the tools, chat-based, BotPress, Flowise as mentioned, and ManyChat. These links will be in the video description, so you can go and take a look at them later on. But each one of these tools offers different capabilities. I'm familiar with Flowise and I've played with LangFlow. The others I haven't had a chance to play yet. There's just too many of them, quite frankly. But if you have experiences, or if you have other tools that are no-code, low-code, that are great tools that we should definitely take a look at, feel free to post in the comments. Next up is the low-code resources. And here we have LangChain, Super AGI, Hugging Face, PydanticAI, and Gradio. And these are low code because they require less code than going straight into LLM or just creating plain framework-less agentic solutions. And these frameworks offer abstraction. They offer utility classes both for memory management, conversation management, flow redirection, and control, as well as system prompts and input and output validations. That's why they are listed as low-code solutions, but they are not visual solutions. They do not have UIs as the previous list. Next is the enterprise tools. So let's take a look at some of the enterprise tools. And here we start with Microsoft Semantic Kernel. Then we have the OpenAI APIs. So you can go straight to OpenAI, and they have great agentic frameworks and they have great agentic capabilities that are being offered straight from OpenAI. Now, one of the considerations here might be, should you use a vendor straight up, or should you use a framework that is an abstraction on top of a vendor? The difference is, with going straight to OpenAI, you kind of tie yourself to one vendor. If you go to OpenAI through LangFlow or through PydanticAI, then you have a layer of abstraction whereby you can change OpenAI for any other LLM in the future, and you wouldn't be so tightly tied to one LLM vendor. So that's just one consideration. Secondly, you can also do the same thing through a cloud provider which offers the same API. So instead of going straight to OpenAI, you could choose going to OpenAI from Azure or from AWS or from Google Cloud, again giving you one extra layer of abstraction, both from cost and AI ops management perspective, but also from a technology resilience perspective. If something were to happen, or you change your mind on using OpenAI versus another vendor in the future, then staying with the same cloud provider, just changing the LLM vendor could be an easier switch over. Then we have Google and the Azure Cognitive Services. Now let's look at the educational resources. And some of the educational resources are the deeplearning.ai website. Offers great videos, great tutorials. FastAI is another tutorial-rich website. Our channel is listed here as well. Andrew Ng's ML specialization course on Coursera, and the AI alignment problem at youtube.com, which is another channel. So great resources. Lastly, let's look at some of the community resources. Community resources in the space of AI agents are rich. There are plenty of community resources available, and in 2025 there's no reason why one of these community resources cannot help you build your first or your more improved agentic flow. LangChain community is there, autonomous agents, machine learning on Reddit, the AI alignment forum, and the LangChain on GitHub has a great community of users, discussions, as well as various Discord servers that are available to help with your questions or issues that you have with this specific framework. I should also remind you that we have a Discord for AI software developers. The link will be provided in the video description. If you'd like to network with like-minded individuals or have a question or a problem, feel free to join the community, post your question or post your idea. One of our community members will surely jump on and help. Now we've come to the end of this short video. So today we looked at AI agents and how to build agentic flows in 2025. We looked at some of the frameworks available, some of the patterns available. We looked at Anthropic's article that came out a couple of weeks ago detailing the agentic workflows and patterns in the landscape of technology. I hope this video gave you an overview of the space. It gave you an idea of the tooling, and it gave you an inspiration to build your agents in 2025. If you like this video, please consider giving it a thumbs up and subscribing to this channel for future updates. Thank you for watching.